Can you hear me back over there? Great. Lee? Awesome. And of course it is necessary to have a picture of a cute dog in my presentations. This is my boy Henry. And this is what I usually see sitting next to me at work. I work in a recliner with my feet up on a lap desk. And he takes his daddy's recliner while daddy's not in it and helps me work in this fashion. So yeah, sometimes I type one-handed for not dirty reasons. I type one-handed because I'm petting him and rubbing his tummy. Okay, what's our time? Oh, it is time. Okay. Let's go ahead and begin. Thank you for being here. I think everyone in the room knows who I am, at least. I'm Ruth Holloway. I'm a member of the board of the foundation. I work for Clearbuilt. We're a little consulting shop based out of just outside Atlanta. We're fully remote, and I have no idea whether we're hiring or not. Talk to this guy in the blue shirt down here and get on his list for when we need extra hands, because sometimes we do. I'm here to talk about optimization. And it seems like I've been with Clearbuilt now for 5.5 years. And coming into that, I had to learn fairly quickly. There were times when we needed, you hack on code, you write some stuff, you create some functionality, and then all of a sudden the page is a little too slow. And in our production environment, merely throwing more CPU at it, or more memory at it, or more disk space at it is not usually the answer. And we're already on Amazon Web Services, so throwing a wider bandwidth at it is not the answer either. We can tell it's the back end, or it's the JavaScript on the front end, or something is going slow. How can we optimize those things? And so optimization became something that I had spent a lot more time on since I came to Clearbuilt than I ever had really ever in my career before that. And I didn't bring a lot of formal training to that. I mean, my last formal training in technology was on Digital Equipment Corporation VAXes. That's kind of a long time ago. Yeah, I can sense some of you going, gosh, I got to look those up. I don't remember what those were. Yeah, they're ancient machines that no longer exist. So here I am for doing optimization on modern web applications written in Perl, JavaScript, with Dancer2 and Debix class in the backfield. And I kind of had to noodle out how to do that for myself. Got a little bit of help from my teammates, who are absolutely the best bosses I've ever worked for. Full stop, fight beyond that, if you dare. But I've had to kind of noodle it out on my own. And so today I'm going to talk a little about that and how I got that way and how I learned the places to look, and then how to do some of that up front when you're creating new code just to save yourself time later. And to have that sharp list of things that can help you when you're creating it so that you don't have to spend time on it later. Where to find the value of premature optimization. Because there is some value to early optimization, but it's a small piece. And you got to find that value and weigh that in your cost. We work on a consulting basis, so we're pretty much per hour so your customers paying for that, and finding that balance of time and money is important. But we got to have cute pictures of puppies because, well, that's who I am. This is Henry. He's my dog. He works next to me very frequently. He lays in Daddy's chair and gets pets while I'm working. Now he has a friend. We have a neighbor in the campground we live in right now, and his dog is named Goliath. Goliath is, as you can see, a pug with a German Shepherd tongue. It always sticks out that far. In warmer weather, it sticks out a little farther than it does in winter, but it's always way longer than his face. His tongue is not optimized for his face. Can we say that? All right. Have y'all seen the HBO series on Chernobyl that was 2 or 3 years ago? It was freaking fantastic. All right, it's a little bit of a dramatization. It is not, if you want to know what happened at Chernobyl all those years ago in 1986, it's not going to give you the whole truth and nothing but the unvarnished truth. It is a little bit of a dramatization. But Jared Harris here, who played Valery Legasov, the scientist from the Minenego Nuclear Institute in Russia, in the Soviet Union, was speaking at the trial of the men who were in the control room and the manager of the plant. And he said, you don't need to be a nuclear scientist to understand what happened at Chernobyl Reactor 4. All you need to know is that inside a nuclear reactor at all times, reactivity, which means power, is always going up or coming down. That's it. And all that the men in the control room are to do is maintain that balance. That's all they do. That's their whole job, is to keep that balance and keep that going up and coming down right around where it's needed based on the power demands of the system. Balance. Balance. All right. Well, just so you know what I'm talking about, this is kind of what our typical applications look like. And my arrows all disappeared here. But we have, the internet out there. And we have a Dancer 2 application that takes care of routing the web pages around. And in the back of that, we have a database engine. In our case, it's Postgres. It could be anything else. And we also, from time to time, use sequential file storage, CSV files that are given to us by the customers or by various instruments and devices they may have. So when I talk about what I'm trying to optimize performance on, this is the kind of application I'm talking about. So you're not just balancing two things, right? You're balancing a whole bunch of things. Optimization costs, the cost of the labor of you doing this optimization, the time it takes you to wrestle through that. If you're salaried and you're working for an organization that has this product out there, that's the boss's job to worry about, not yours. If you work for a consultancy like I do, it's kind of mine too. And so I end up telling Neil, okay, to speed this up by so much, I expect that it's going to take a few hours. And he goes, okay, fine, go for it. Cost of memory and CPU resources. We know about those things. Cost of disk and DB resources. The bigger your database, the more disk it takes, so on and so on. We know these things versus the cost of letting the customer be grumpy about their page being slow. And I say that in kind of a funny way, but there is a cost to that. Grumpiness from your customer in our environment equates to eventually they go away. And that's kind of not okay. We don't want that. So, but balancing that is the dance. What was it that Valery Legasov said? The invisible dance. Right? He called nuclear reactors the invisible dance, which can power entire cities without smoke or flame. This is the invisible dance that makes fast web applications as cheap as possible. Some of my text is not very well colored because I didn't get it all changed because I switched to light mode. This is Vasily, crap, I don't remember his name. Let's do this. Yep. Where'd it go? Come here. It put me on the wrong screen over here. I'm going to drag this over. Change this real quick while I'm while I'm here. Yeah. And it micro-sized the whole application. Darn you. I'm trying to remember the first guy's first name. His second name is Pareto. You might have heard of him. And the next slide has the same problem. Fix it. Done. Shift F5. Go. Vilfredo Pareto. He was an Italian. He was an engineer and economist, polymath. Does anybody know what his name is a reference to? The Pareto principle? Yes. But he didn't think up the Pareto principle. Now you're starting stuff with. But no, he's a reference to the Pareto principle in this context. But he didn't actually come up with it. He observed that 80% of the land in Italy at the time he was around and professionally working was owned by 20% of the landowners. And he noted also that in manufacturing, 80% of the salary was given to 20% of the workers. That's all he noted. He wrote about it, wrote a book about that. Somewhat later, in 1941, Joseph Jurin was reading that. He's an economist, also an engineer. And he said, I wonder how much that 80-20 thing shows up elsewhere in our world, our modern world. And so he noted that he was doing quality control work during World War II, and he noted that 80% of the problems, of the flaws, came from 20% of the causes. You have this long bell curve, this long tail of things that only crop up once or twice. But the big problems happen in this narrow, if you solve these problems up front, you eliminate most of your problems. And he called it the Pareto principle after Pareto. But he's the one who thought that up the way we think of it today. And he said, originally he said the vital few and the trivial many. He would later change his own wording in the 60s and say the useful many, because that long tail of problems are not trivial. Some of those are useful to solve, but they're not as important as the 20%. So, we get then something like, we see this, and no, it's actually not important, it's just less important. Effort versus results, and that's the Pareto principle, the way we think of it in the 21st century. Well, how can we apply that to optimizations? We'll get there. Robert Heinlein, my favorite author, said this: neither common sense nor logic can prove anything. Proof comes from experiment, or to put it another way, experience, and nothing else. A scientific method requires experiential data before you call it a law. It's a theorem before that, until you have experimental data that shows that outcome. Same thing with common sense. It's not common at all. The phrase is self-contradictory. Sense is never common. Robert Heinlein again. So if you're going to do optimization on web applications like the ones that we do, you probably need a toolkit. Let's start with Time High Res. Time High Res is a fantastic module because you can get down to the microseconds if you need to. But if you just reference time, you're getting a number of seconds with a whole bunch of decimal places after it. And then you can slice and dice and add and subtract and do lots of cool things with that and find out how long is this really taking in real world terms that I can understand, because saying something takes 48 milliseconds doesn't mean anything to me. I happen to know, because I'm a nerd, that's pretty quick. But to get out of your application, in your warnings, in your tracers that says, this took 5 seconds, this took less than half a second, then you start to easily see the gaps. Data dumper. Does anyone not use data dumper, at least sometimes? If you just need a quick, hey, what's this doing? Data dumper is your friend. And ProCritic will fuss about you leaving it in your application. We kind of ignore that. We're like, fine, leave it in there. We can use it. Because we will use it. What's this application doing there? Dumper it. A largest test database. We find when you've got a brand new application that's talking to a database back there, it runs nice and fast. And as the pile of data accrues, as the application is used, then it gets slower and slower and slower and slower. And so if you've got a nice big test database, that helps you hunt down those slow spots a little easier because they're not measured in fractions of a second. They get to be measured in full seconds. This is a little controversial. Well, maybe. A stopwatch. Probably you have one on your phone. I actually have a big mechanical fancy one. The timings you're getting from your back end, from your Perl application are one thing, but that doesn't take into account what's going on in the network. That doesn't really tell you any of that. And it doesn't really tell you much about what's going on in your front end if you're using JavaScript, for instance. But a stopwatch will. When you hit enter, when you see the page and it's ready to use, turn it off. There's your time. I love my stopwatch. I don't use it every day, but when I'm going front end and working on that, which I'm doing more and more these days to my great pleasure, a stopwatch is nice to have. That's toolkit. Now, the 80-20. The 20% of things that cause the slowness. In your application, I could say common sense says these things. I'm not going to say that because your applications are going to be different. Because they weren't built by Neil and Mike and me and other people that have worked for our company. The way you build your applications, you may already have them resistant to these kinds of problems, and so you don't have those. Experiencing and digging into your own code and your team's code will help you find the 20% of problems that will solve 80% of your speed issues. And that is totally an exercise left to you. I can't do it for you. Well, unless you hired me, but I'm not looking. Okay? Here's some common ones that have cropped up for us that may also be one of the problems of yours. Undefined value. Are you not getting undefined value warnings? Are you using warnings? If you're not using warnings, use warnings. If you're not using strict, use strict. I don't know how else to say this, but frankly, if you're not using strict and using warning or using modern Perl, I really don't know how to help you. They are the best tools you can imagine. And using warnings or modern Perl will give you things like you're trying to add on an undefined value. You're trying to add on an integer that is not an integer. You think that's an integer variable, but it's got a string in it. You think it's numeric, but it's not. It's got the letter E in it. You haven't properly translated it. You get these undefined and defined as warnings, you start seeing those in the log. Not only are they speed problems, if there's a whole lot of them, but they also can point the finger at a lot of logic bugs. So that could be solved. For instance, say you're taking a bunch of database records, you do a data select, and you get this long list of records. However you do that, whether it's DBI like Matthew Persico does, or DivX class like we do, or whatever you're using to select your database records. You select a bunch of records, and then you want to look at this field that you know is either numeric or null, because you assigned it numeric but didn't say not null, and you want to add 2 to it. And you start getting undefined value in addition when you try to add it to the ones that are null. If you only wanted to add it to ones that are not null, make your select better. Throw away the ones that are not null instead of looping over them and saying, oh, that one's null, next. So if the first thing you're doing is saying, next, if this value is null, you probably ought to be doing that, let the database do it, instead of looping over that. It's a real common construct. I see this all the time in our code. I do it all the time in our code, and then have to go back and go, no, don't do that. You have a for each loop for all these records, or a while loop for you're using next, to pick off your next record. And the first thing you're doing is saying, next if some condition is true. And it's a condition that totally could be used in DivX class to select away those things. Let the database engine do the work. It's way faster at that than you will ever be. And it's way faster at that than Perl will ever be, too. Because it's optimized for that. It knows how to do that and do that very quickly. Same thing for sums. Okay, you've got a table full of order line items. Each line item has an item descriptor, maybe a link to a table of products. You have a quantity and an each's price and a total price. The total price you probably shouldn't be storing in the first place. Calculated at runtime. Let your front end do that even. Let JavaScript do that, because nobody cares about that. It's just display. You're going to multiply it anyway. Let the database do that. There's sum and multiplication and all kinds of tools you can use in the database. Matthew Persico pushes, database functions to do that. Parameterized database functions to take care of some of that. For the things that aren't already built in, like sum and count. Concatenate for strings. Avoiding these undefined warnings, on their face, it's not a big thing. Yeah, I'm adding 1 to a number, and if it's null, it comes out 1. Okay, fine. In Perl, we know that. But it may be pointing at either a logic bomb, because you're getting something you don't really expect, or the possibility that the database could be doing more work for you cheaper. Abigail.
The problem with having the database do more is that if you have 1,000 threads in your database, if you make your thread cause the database doing more work, the other 999 threads are going to suffer.
Absolutely, and that's very much, if you have 1,000 threads in your database because you have a very, very large application like booking, then you adding more work to the database may slow down the others. And that's true, and that's part of that whole balancing thing. In our application, that's not too big a problem, because we only have 3 Nginx workers, or 4 in some cases, running. So that's as many hits as we're going to get at a time. So we're throttling it elsewhere to prevent that kind of problem. And the threads of the database, it's not that much bigger than the 3 or 4 workers we have at any given time. That's our application. You absolutely are correct to point out that your application, that might not be the best solution, to throw more work at the database. And that's why I say, I can tell you all kinds of common sense things, but they're common sense things for me and for my colleagues at Clearbuilt, and possibly for some people who do similar sorts of work. If you're doing monster applications, big killer apps, or fiddly little one-offs, your mileage will vary on that one. And again, it's all part of that multi-plated balancing act that you have to do, is figure out where the pain points are and figure out what the possible answers are and find the one that works in your app. Here's one, though, that I think is perhaps a little more general. Big loops. Big loops, because if you do 10 instructions in a loop and you have 10 records that you're feeding into that loop, you're doing 100 instructions. And every record you add to the database after that, you're adding 10 instructions. Mathematically, that gets big in a big hurry. The more work you're doing inside the loop, the bigger it is as a target for high value optimizations. Can you farm that work out to another process if you're working in a multi-threaded application? Can you farm that out to the database if you're not writing a great big database app? There's all kinds of possibilities, but these are a big target to look at. So when Neil says, when he messages me and says, Ruthie, could you look at this page? It's running slow. They're fussing about it, or I noticed it, or whatever. It's running a little slow. The first thing I look for is great big loops. If we've got a loop that's doing too much work, take some work out of it. Somehow. How you do that is part of that balancing act. Work it out. Some of it's going to go to your, in our case, taking that kind of thing to the database is absolutely a good idea. For Abigail's situation at booking.com, it might not be. Might be in some cases. But this is the first place to look. When you see how much work you're doing there, every instruction you remove from those 10 removes large numbers of instructions from the work once you've got 1,000 records. You're removing 100 a pop. Third piece is the last one, the last real nuts and bolts stuff. Repetitive or needless I/O. How many of you are not using file slurp in your applications when it's time to read a file? Okay, well, there are ways and ways. Tim Toady is in fact a thing. But file slurp is kind of neat because if you know that the file is not aggressively large, then file slurp is nice because it goes out to the file system, reads the whole thing, puts it in memory. Done. And you've saved a lot of real-world time of spinning up a hard drive and looking at sectors and doing all the real-world physical things that spinning hard drives have to do. Now, if you're on SSDs, that's a little different. But real-world interfaces, whether serial or file system or whatever, the more you can do at a big chunk, the better. Instead of reading character by character, can you buffer that some way so that you're reading chunks and chunks and chunks? Walt?
Because the operating system is buffering it, but it's not reading it one at a time, it's reading it a big block you want to give it.
Right.
And it's easier to read the code if I'm reading all that one at a time.
Right.
Yeah, because for file slurp, you have to wait till an action has read everything from the disk. Well, if you're processing it line by line, you only have to wait till you have the first line, and then you...
Right. And there are ways and ways. And we've found, it depends rather a lot on the size of the file and how big your buffer is. If you're reading in very small files, getting it all in the buffer at once is fine, which you're going to do by any kind of read operation you do. And the broader point is, watch out for real-world operations. We have an application that on the front end side talks to scanners and to barcode printers. And the real-world timing of that, a little painful. Partly because JavaScript is asynchronous. You tell it to do something, and unless you tell it deliberately to wait until it's finished, it will not, and it'll just charge right on ahead and go do other things that you may not, in fact, want it to do, including, like API calls over the network. You say, issue an API call, then do something with the results. If you don't tell it you got to wait for the results, it won't. And then you don't have any results, and it does nothing. I stub my toe on that one all the time. And async await is painful to use. Ajax, done, success, finished. Those are a little easier. We've kind of narrowed in on how we do that to keep the pain minimal. But pay attention to your real world stuff. If you're reading a very large file from disk, think about how much real world stuff has to happen versus how much of your operating system buffer versus can I store this somewhere? Can I, do you want to do that as an external process and stash it in a temporary table or a SQLite file or whatever? How do you want to do that? If you're working with SQLite, you're doing some of that all the time because it's just a file. You had your hand up there.
I did. I have a question that's somewhat relevant, but sort of reversing roles.
Yep.
You were at my last talk.
Yep.
I have a situation where I'm piping data from one process to another, and it keeps blocking because the process it's piping to is not fast enough, and the buffer fills up, and then it has to sit there and wait for the buffer to clear. It's a pipe, so it made the buffer as large as Linux supports, which unfortunately is 1 meg in my situation. How would you improve the performance of something like that? My thought was writing to a file, but these files can get so big they take up too much temp space. I don't want it to maintain the lines. It's already read.
Right. I would be tempted to try, and again, there is no proof until you experience it. I would be tempted to try in that circumstance, having a process. Oh, yes. Chad asked, he's got a process that he's piping from one process to the other one and occasionally blocks because the buffer in between, which is as large as Linux allows, is full because it's piping in way faster than the ingester can eat it. Did I summarize that correctly? Okay. I would be tempted to try, and this would be very much an experiment for me, would be to try to put a third intermediate process in there that stored it. You could use a memory file system if you've got enough memory. You could use your database engine if you've got some sensible key there that you could pull it back out of fast, and then delete those as soon as they're processed. Have the third process deleting them as they're processed.
So I looked into that. Some people have done that before. First problem is that consumer process, its entire job is writing to the database. So having something between to write to the database won't help.
Yeah.
I've also tried adjusting the process so it slurps in everything even before it starts its loop to process it. And the problem then is it's slurping so much that it doesn't actually start its processing until the first process is finished.
Mm-hmm.
So my problem is there's just too much data in between.
Yeah, and my first experiment would be to put a man in the middle.
Given a producer and a consumer, one of them is going to be faster. You can't make them.
Right, but I don't want the producer to block on the consumer.
Be in the same box.
What was that?
You have to be in the same box.
Yes.
It does have to be on the same box.
How about not for consumer?
I've thought of that too. That's probably too much of an interruption to the talk.
Oh, yeah. There, and here we get to the point of a lot of this is what might work for the problems. If I had the same problem, say with inspection records, if they sent them all in one big, I might have the same problem because that inspection routine is lengthy. We would have the same problem eventually at some point. And what might work for my system, for the solution I'm working on, might not work for yours. Don't be afraid to experiment, first of all. And yeah, that costs a little bit. Don't be afraid to ask your colleagues, and as Chad just did, elucidate the problem. Give us some info on Where's the pain point? The pain point is on the consumer process is too slow. Well, can we look at speeding that up? Would it help? Maybe, maybe not. Again, you have to keep digging, keep digging, keep digging. Common sense isn't common, kids. We know that. If it wasn't, we wouldn't have had 2 world wars and the world in the situation that it is in, yes? Common sense isn't common, or we wouldn't be where we are. The long and short of it is that you need your own toolkit. And you will find that your toolkit doesn't just include a couple of modules and a stopwatch and a big database. Over time, as you do this a few times, your toolkit may include bits of code. You know, I found if I change this, then that whole kind of structure works a little better. Oh, well, we use that kind of structure a lot. Let me go change those. And then you start doing it up front so that you never are bumping your head against this in the first place. Okay? Fair enough. Go ahead and get your hands dirty. You ain't going to talk it through on your own. You're going to have to dig in there. Get your gloves on. I know if you're working with code that's 7, 10 years old, as we do in a couple of our systems, it's dirty. It's ugly. Because, hopefully, all of us, all the time, are learning to do this better. I hope so. My bosses tell me occasionally that I'm novel because I do that. That I'm somehow different and special because I'm forever trying to get better at this. But I'd like to think that most of us are at least interested in the notion of getting better all the time. They are. Anytime I say, today I learned, they pipe right up. Hey, that's cool. I'm going to try that too. So, are you willing to get your hands dirty in somebody else's code to learn to do this better? You need to be. I have met some prissy devs, especially younger ones, who were like, I don't like other people's code. Okay. Like, fine, jerk. Get some wins. Once you get a couple of wins, especially easy, get a few easy wins. You're going to find a couple of big loops and you go, oh, you know what? By changing my select, I can avoid that big loop. I can not have to do that. I can take this next out of a loop by changing one thing over here. Oh, hey. If you change the terms of a select that you're going to do anyway, and it chops away a third of the loop, you just got a big win, cheap. Get you a few of those and get to feeling good about it. And get, the people who depend on you to do this kind of stuff feeling good about that. And you'll find, as I have, that you become the subject matter expert on that. And Neil doesn't bother optimizing code like that anymore. He just says, Ruth, would you take a look at this one? And I'm happy to do it because that means better, faster, stronger for our customers and makes my boss happy. And then those snippets of codes, you can start including them on your first iteration. You found out that next if not defined this database field is slower than merely saying using DivX class more helpers or DivX class helpers and looking for not null in the select. Saves you a bunch of time. Then you can start doing that thing right up front and converting the ones you see when you go in to do maintenance on the fly. And that's where the win is. And then you look like, oh, that's just common sense. And you can snicker to yourself knowingly, ha, 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 ha. Common sense isn't common. We all know that. Ha, 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 ha. While your applications run better and faster, and your customers and your bosses are a lot happier about it. Those are just some of the things I've learned. We do have some time. Questions, possibly answers, maybe suggestions. things like Chad's question down here, where he asked about, I have a producer and a consumer, and the producer is way faster than the consumer, and so we end up with a clogged pipe. What are the kinds of scenarios you have dealt with when trying to break speed problems? I know it's the third day of the conference. We're all tired.
Yeah, I've thought of that, and it's hard to break these out because it's basically writing a bunch of database objects, and every bit of input might affect the others. So
Yeah.
Perl is hard. So that's what I'm going to fall back to if I can't find something better. Is I'm just going to write it all out as a temp file in the RAM disk and then read it in. But I don't want that, like the stuff I've already read in, to sit there, which is why I'm trying to avoid that solution.
And why is the consumer slow? What's the bottleneck?
Database.
Have you tried putting the database on the
Yes, it's already on the
Good suggestions there. The suggestions were to utilize a RAM disk either for the data itself or for the database itself, which has been attempted. And so those are suggestions, and that's good. Yep.
They use DBIS class.
I do.
I mean, isn't that what it's supposed to do, is split things up into small packets?
I'm using populate, which is the fastest way DBIS has to insert as far as I know. It's still taking a while. Part of the problem is it has to read a bunch of objects until it gets to a point where it goes, okay, now I have enough to flush, and then it flushes it all through. And now I can't write intermittently because of that.
Right. Because then you'd have to be doing update on all the things that depend on each other, which then just increases that burden, as Abigail pointed out earlier. Okay? Lee.
Just in your token, I would substitute
Data printer for data dumper? Yes.
It's not hard, it's so much better than yeah, for human people, yeah.
More human readable? I'm all for that. I think that's a good idea. We have tried using CARP instead of Warn. I haven't seen a real difference in what I do. But yes, you do have a lot of choices. Data printer instead of data dumper. I use data dumper because I'm old and gray-headed. Well, sort of. And I'm so used to it. But data printer is absolutely another option for that. Using Carp and Croak instead of Warn and Die. Other people find meaning there.
Going to raw DPI is faster than digital class.
Right, because there is an overhead in DivX class. And occasionally going to raw DBI can speed that up.
Yeah, I mean, biggest optimization that I've done in my work the last couple of years is not so much speeding up how fast you go to the database, but in the application spend a considerable amount of time optimizing the number of times you go to the database.
Right.
Because going less often to the database is a way bigger speed up than individual.
Right. And we've done that in some of our...
And all in, of course, in broad DPI, no, nothing.
Right. Whether you're using DivX or DBI raw, either way, we have some cases where it's worth it to use, what is it, get all hash ref or get all array ref instead of getting them one at a time, because of you're hammering on the database. You're making a bunch of requests on the database. And, especially if you're prefetching, and you're prefetching a bunch of stuff that you already have in the data, and you're going to pipe it out to the browser in an API, maybe in JSON, to display in a grid. We do a lot of that. And we want to be able to say, select these things. Here's what the rows look like as a hash ref, all. Send it as JSON. Done. One line. because it avoids next. You know, next and push and next and push and next and push and next and push. And it avoids a bunch of hammering on the database. But if you can tell the database, if it is saying to do so, give me all this in one pop. Now, if you've got hundreds of thousands of records and you do that, well, you get the punishment you deserve. But if you've got 100 records, using get all, using whichever dialect you're speaking, is absolutely a win there. Any other thoughts? Walt?
Going back to the slow COBOL programmer at QVC, that I think they applies to everything. One thing the system we had was the best tool there was a code profile. The Stratus computers have very good ones. And what you do is you can send a few records through, you can run a report or whatever, they can build code that was slow, and it would tell you how long the computer took to execute every line in the code. You can have it in line, you can have it sorted by runtime, and very often you would find it's hard to predict which of the lines is going to take the longest. And also, it's like not even the 80, not 20 roll. It might be 1 or 2 lines that are taking 90%, 95%.
Oh, sure, yeah.
And unexpected, there are things like when you're calling something to parse timestamp, and maybe you can just do it in line because the year of the month and the day are always in the same position. Why use a regular expression to parse that when you know they're always fixed positions?
Yeah, just split it apart.
That was one thing that we ran into, that there was one system call
Yeah.
that was just super slow. We got rid of it, and all of a sudden the code ran 10 times faster.
Yes. What Walt is saying for the tape, and for those of you that are farther away from him, using code profiling tools can also help quite a bit, because it can isolate things that are going to system calls and taking a lot of work. And you can look at the 20 lines of code in a block and see that this one line is the problem. I'm working on something similar right now. In fact, I have a page that returns 5 bundles of JSON. And when I added the 5th one, it all of a sudden got really slow. Well, obviously, the 5th one is my problem child. So now it's a matter of frittering into that. And you can drill in profiling tools if it's not obvious, like this one is. Profiling tools absolutely can help do that. That said, profiling is a little harder in Dancer applications because you've got plaque and you've got all these layers of... Yeah, to be fair, it is hard in a bunch of applications, but I know that... Right. It adds to the problem in some cases. And I know that as of a couple of years ago, Devel NYT Prof doesn't play well with Dancer. I've never tried it, but I think it was you, Mike, that told me that.
No, we used it, but there's no Dancer 2 plugin for it.
Aha. So it doesn't play well. And so we need better tooling, frankly, but.
So just an update. So you suggested the man in the middle. That was also my conclusion last night when I was looking at this, but I didn't have time to do it. But I did Google around, and there are utilities that act as that man in the middle. There's a tool called Buffer or happen.Buffer, depending on which Linux you're on. You can specify a buffer of like a whole gig or whatever, and you basically pipe to it and then pipe from that to something else.
Excellent. So you don't have to build that man in the middle yourself.
I am going to try to stick that in the middle to see if that helps. I just didn't have time to do it.
Sure. Okay.
I'm hoping for an easier solution.
Well, yeah. Chad is pointing out his problem of consumer and producer mismatch, speed mismatch. There is a Linux application called Buffer or mbuffer that you can put in the middle and pipe to that and then pipe from that. And you can specify the size of the buffer you want instead of just getting the default pipe buffer size. You can even go like way bigger than Linux normally would go. So he's going to attempt that, see how it does, which is exactly the right thing to do. Let's try this. And it seems like the cost of doing that, the cost of the exercise is not high in that case because it's an application that's already built. Just install it. You're not having to build that man in the middle yourself in this case. All right, any final thoughts? No? Wow, well, I appreciate you being here. I know I've been on stage rather a lot this week, and there's more to come, I assure you. But I appreciate your time and attention this morning. Right? Thank you.